All right, okay. Let me try to explain to you how to integrate with parameters in basically parametric equations. Okay, so let's say we have a pair of parametric equations given by this x equals 2t squared, y equals to t. Pretty simple. Well, this is the pair of equations given. The t is a parameter. So t basically links x and y. If you want, we can remove t and we can get an expression in terms of x and y called Cartesian equation. However, that's all that you know already. So what I'm trying to explain to you how to do an integration using this. Now, integration would be normally, as we know, in integration means this y dx. That is the Cartesian integration form. Cartesian integration form. That's the Cartesian integration form. Means in terms of x and y. Now you might be wondering, what is this y? It is like saying, for an example, let's say we had y equals to x squared plus 2x plus 1. They're going to ask us to integrate this function or the expression. So what you would do, you would integrate basically x squared plus 2x plus 1 in terms of dx, aren't we? We do that. Or you can say, because that is equal to y, so I can say, I'm doing the same thing, y dx. See? So we would use this as a basic format of integration. Basic format of integration. So we can actually use this to find the area under a curve and all that. That's the whole idea. However, here we're going to use the Cartesian equations, these ones, in order to get this. Okay, that's the game. So let's see how we're going to do that. Now, we know y is already equal to t, isn't it? So we can just replace y with t. Okay, it's pretty simple. And however, dx is required here. Now, as we can see, this function is given in t. So we can't have a dx there because we can't differentiate t in terms of dx directly. We can't integrate t in terms of dx directly or in terms of x. But however, we can do a small trick. Instead of writing dx, I can write here this one like this: dx dt times by dt. Here dt means delta t, small amount of t, isn't it? Same as dx. So we can clearly see they cancel out. See? When they cancel out, again we get the same expression. Y dx or t dx. That's exactly what we're going to do. So instead of using that, when we get parameters, we're going to use this. Or in the general case, y dx dt. So here we can say, right, so t is t, dx over dt. So we can differentiate x in terms of t. So what I'm going to get is 4t there. 4t times dt. See, once I differentiate that, I'm going to get 4t. And that is dt outside. Now I can integrate this one easily. So what I'm going to get there is basically I have 4t squared dt. 4t squared dt. When you integrate that one, we're going to get 4t cubed divided by 3 plus c. That's it. It's pretty simple. Let's do another one. Okay. So let's say we try to, we have another parametric equations given by x equals sine theta, y equals cos theta. Let's say we try to integrate this one. We try to work out y dx. This is what you're trying to work on. Sorry. Basically what we're saying, we're trying to integrate y in terms of x. Now the theta is a parameter now. Before it was t was a parameter. So here what we can do the exact same thing. Now y, we know it is cos theta. Now write on cos theta. Integral sign. Dx can be replaced with dx over d theta times by d theta. It's like a trick. See, they cancel out again. We're going to get again cos theta dx. Now we can do that. Cos theta is cos theta, rewriting it. Dx over d theta would be, going to differentiate that. Going to have cos theta d theta. So what I'm going to get here, cos squared theta. Now I can integrate this one using the method of integrations, like using double angle formula or something. That's probably, you know how to do that. Okay, I think that's basically it. So it's not that very hard. It's very straightforward. All right, cool.